So in this video, let us look into the converse of basic proportionality theorem. Now that we've seen the basic proportionality theorem, the converse of it should be pretty much simpler. Now let's see what it says. So here it is. This is what the converse of basic proportionality theorem all about. If a line divides any two sides of a triangle in the same ratio, then that line must be parallel to the third side. If you just recall a little bit and go back to the basic proportionality theorem, it said something like this. If a line is drawn parallel to one side of a triangle, intersecting the other two sides, then it divides the other two sides in the same ratio. That's what the basic proportionality theorem said. Now this is not very different. This is just the reverse way of saying it. It's like if a line divides any two sides of a triangle in the same ratio, then that line must be parallel to the third side. That's what it says. Let me quickly draw a figure and explain the same to you using a figure. So let's have a triangle ABC. Now, if I divide the sides AB and AC in the same ratio of this triangle, say for example, by drawing a line like this, DE, my focus is now to divide the lines AB and AC, the sides AB and AC in the same ratio, not to draw the line DE parallel to BC. So my focus is different. So if I'm doing this, then automatically what happens, DE becomes parallel to BC. That's what it does. But then if you go back to the first theorem, let me show you that what I did there. That is, if you go back to the original basic proportionality theorem, say we have a triangle ABC. Now my focus here is to draw a line that is parallel to BC, something like this. So I'm concentrating on this point, that this line should be parallel to BC, and in the process it intersects the lines AB and AC at D and E respectively. So if I'm drawing the line DE parallel to BC, then it intersects the lines AB and AC in the same ratio. It cuts the lines AB and AC in the same ratio. That's what the basic proportionality theorem said. The converse of basic proportionality theorem is nothing but we are not focusing on drawing DE parallel to BC, but then we are focusing on intersecting the lines AB and AC such that it divides them in the same ratio. When you're doing that, automatically DE is also parallel to BC. So that is what it says. So that is the converse of basic proportionality theorem. So this concludes the video. I'll see you in the forthcoming videos with maybe problems based on basic proportionality theorem.